Hi there. So this lesson is over the operations of functions. The big idea here is that you can multiply two functions together to get a new function. You can divide two functions to get a new function, as long as the bottom function is not equal to 0. And you can also add two functions together. And of course, if you can add, you can also subtract two functions from each other to get a new function. Now you may be wondering yourself, why does this matter? Who cares? Well, here's a quick example here. If you are trying to find your revenue, let's say you are selling shirts, okay, and the price of your shirts is P is equal to 20 minus 2D. So you start at $20 per shirt, but you find out if you decrease you can also decrease the price of the shirts by $2 each time. When that happens, the number of shirts sold right here, 10 plus 6D, for each price decrease, you sell 6 more shirts. Some of you are familiar with this because we did a project over this. So for each price decrease of $2, you sell 6 more shirts. So how can you find the revenue? Well, the revenue is going to be how much money you've made total. So you're going to take the price times the number of shirts sold, whatever that is. So if the price were $20, you would have had no decreases. $20 times 10 shirts sold, you'd have a revenue of $200. So the revenue is the price times the number of shirts. Now, it turns out, though, that we have an equation for price, so we can just plug that in, 20 minus 2D, and multiply that times 10 plus 6D. So in this case, revenue is equal to P of D times N of D. Or we can also write that as P times N of D. And if we're going to go ahead and work that out, revenue is going to be equal to, well, we could distribute this, 200. We're going to get subtract 20D plus 100. Plus 120D, so it's going to give us minus 100D, and then minus 12D squared. And from this, we could find the maximum revenue and how many price decreases we would need simply by finding the vertex right here. D would be the number of price decreases, and the y-axis right here would be, the r-axis, would be the maximum revenue. D would be the proper number of price decreases to find a revenue. We're not dealing with that right now, though. We're just learning that, hey, I can multiply two functions together and get a new function. Not rocket science. It's a pretty simple idea here. Continuing this kind of analogy with shirts here, okay? If your revenue is R of T, so that's how much you made, like up here, okay? Where T is the number of t-shirts sold. And your cost for each shirt, well, let's say you have $100 right off the bat that you have to pay just for rent or for heat or whatever it may be, or for the ink, and you buy the shirts for $4 per shirt. So your cost, if you buy, for example, 20 shirts, is going to be 100 plus 4 times 20 shirts, $80, $180. But you're going to be selling them for $20 a shirt. If you sell 20 t-shirts, that's your revenue. So if you want to find your profit, P as a function of T, we would take to find the profit, we would take our revenue minus our costs. And so P of T is going to be equal to R of T minus C of T. Or we can rewrite that as R minus C of t. It's the same thing, really. So our profit is going to be 15t minus 100 plus 4t. Please note that I'm putting these in parentheses because it's substitution. And so once I actually work this all out here, the profit, I'm going to get 15t minus 4t. I'm going to be earning $11 per shirt. But my profit, I'm already $100 in the hole, so looks like I'm going to have to sell, just over 9 shirts to start making money here. Okay? Just over 9 shirts to start making money. And, of course, if we were to graph this right here, we'd start at negative 100. And we'd go up 11 over 1 for each shirt. And 9 shirts would be right here. So it's going to be just a little bit more than 9 shirts here. At 9 shirts, we'd actually start making money. And this is our profit. This is the number of t-shirts. And once again, this is not, we're not dealing with this. We've already talked about this year, but we're just showing that the big idea here is if you have two functions, you can add them together, subtract them, multiply them, divide them. And when you're dividing, though, you just got to make sure that the bottom is not equal to 0. Can't have 0 on in the denominator. Divide by 0 and puppies die. The other big idea we have here is that you can plug a function into another function. We normally call this f of g. All right. It's not a huge idea. Well, it's a very common idea, but it's not extremely difficult. You can plug a function into another function. Now, you may say this is completely foreign to us, but not really. For example, if I said f of x is equal to the square root of x, and you were to say, and then I were to say g of x is equal to 2x minus 1, then f of g of x is really just taking g of x and plugging it into f of x. So f of g of x is really just f with g of x inside it, which is just, so g of x is, plug in 2x minus 1, because that's what g of x is. And since f of x is the square root, it's going to be the square root of, instead of x, I plug in 2x minus 1. So what we have here is, instead of the x value in here, I'm plugging in 2x minus 1 where that f of x was. The g of x right here is shoved inside, and that gets put where the x was in the other function. So that's how you just plug a function into another function. Not super hard. The last thing we have here is the domain of new functions. So let's say you have a bunch of numbers here where this is f and this is g. This is the domain of f, and this is the domain of g. Where they overlap would be the numbers that you can plug, would be the domain of the new function. We'll look at this in greater detail later, but here's the basic idea. If I have, let's say I have the square root of x is f of x, and let's say g of x, well, we'll just stick with 2x minus 1, like we did in the last example here. If my new function is f plus g of x, that means the new function is going to be square root of x plus 2x minus 1. Now, what's happening here is the domain of f, well, we know we can only plug in numbers greater than or equal to 0 into a square root function. Otherwise, we get imaginary numbers. So the domain of f, in this case, is all numbers x is greater than or equal to 0. In straight lines, though, we can plug in any real number. So it's all real numbers. So where do these two overlap? Well, this says I can plug in any number. This says I can only plug in numbers greater than or equal to 0. So the domain of my new function is just, I'm limited by the domain of f. So I can only use the numbers, so x's have to be greater than or equal to 0. All right? So if I need to find the domain of the new function, really what I normally do is I just look at the new function and say, hey, what numbers can I actually plug in there? I can only plug in numbers greater than or equal to 0. But this is how you would graphically look at it right there. On to the next part. All right, now here are some examples. If you have to find f times g of 4, no problem. I'm going to take f of 4 times g of 4. And since f of 4 is the square root of 4, and g of 4 is 2 times 4 minus 1, I'm just going to multiply those two together. That's going to give me 2. That's going to give me 7, and I'm going to get 14. No problem, right? F plus g of 9. Well, I'm just going to take f of 9 plus g of 9. Just plug those in. Square root of 9. That's f. G of 9 is 2 times 9 minus 1. And that's going to give me 3 plus 17. 3 plus 17 is going to be 20. No problem. F of g of 4. All right, well, we know this is f with g of 4 shoved inside it. So g of 4, for g of 4, I'm going to plug in 4 into g. Now, if I plug 4 in there, that's going to give me 2 times 4 minus 1, which is going to be 7. So it's really just f of 7. F of 7 is the square root of 7. That's all I got to do. I'll plug 4 in here. G of 4 is equal to 2 times 4 minus 1, which gave me 7. That goes right in there, just like that. Now, we can also switch it up the other way. G of f of 4. Those are not going to be the same thing. So G of f of 4, well, f of 4 is the square root of 4. Which is 2. So really, I'm just taking g of 2, because that's f of 4. And g of 2 is going to be 2 times 2 minus 1, which gives me 3. So that's how you plug functions into other functions. Just plug g of, if you have to find f of g of 4, write it like this. I find this the easiest way to write it, not like this. But g of 4, I'm going to find out what g of 4 is, plug it in, then take that number and plug it into f. If I wanted to, I could have written it like this. F of g of x, f of x is the square root, g of x is 2x minus 1. So what I really could have done here is the square root of, if I want f of g of 4, 2 times 4 minus 1, which gives me square root of 7. If you find this easier, go ahead and do this. This is also valid. Some people like to do it just step by step. Some people want to do it all at once. It's up to you. Next way this can happen is as in the form of tables. So f of g of 5, same thing though. It's going to be whatever f of 5 is times whatever g of 5 is. To do this, I just have to look at the table and figure it out. F of 5, if x is 5, then f of 5 is 4. G of 5, if x is 5, then g of 5 is 10. So my answer is going to be 40. F plus g of 4. Well, I'm just going to take f of 4 plus whatever g of 4 is. F of 4, if x is 4, then that means f is 3. If x is 4, then g is 1. I add those together and I get 4. F divided by g of 1. Well, I'm going to take f of 1 divided by whatever g of 1 is. F of 1 is 6. G of 1 is 5. And so my answer is just going to be 6/5 or 1.2, however you want to write it. The next one, f of g of 2. Well, I'm going to find what g of 2 is. G of 2 is 7. F of g of 2. So f of 7, because that's g of 2, right there. And f of 7, if x is 7, then that means f of x is going to be 12. So once again, I'm just plugging in. Since I know g of 2 is equal to 7, just substitute and plug it in there. The next one, f of g of 3. Well, f of g of 3. Work this out and I find g of 3 is equal to 3. So I'm going to have f of 3. Look over here at my table. Oh, that's not in our domain. That's not a valid number we can use. So the answer is does not exist, or no solution. Even though g of 3 existed, there's no value for f of 3 here. There might be a hole in the function, or maybe it just doesn't work. But g of 3 is not a valid value, so there's no solution to this. All right, last part here. Find the domain and range of f of g of x. Well, this is an example of what we did on the front here. I got to find the domain of g of x. The domain of g is going to be 1, 2, 3, 4, 5. The domain of f is 1, 2, 4, 5, and 7. So if I want the domain of f of g of x, I got to find out where these two overlap. Well, they overlap here, overlap here, overlap here, and overlap here. So that's what's called the intersection. If we went back to that chart over here, if this is f and this is g, f has the numbers 1, 2, 4, 5, and 7. G of x has the numbers 1, 2, 3, 4, and 5. Where they overlap, that's the domain of the new function. So the domain for f of g of x is going to be 1, 2, 4, and 5. To find the range, well, I'm just going to go through this one at a time. F of 1, g of 1 is 5. F of 5 is 4. Let's plug in the 2 now. The 2 for our new function. G of 2 is 7. And f of 7 is 12. Three is not in there, so we can't use that. G of 4 is 1. F of 1 is 6. And G of 5 is 10. f of 10 is, oh, that one doesn't work. So I can't, so I actually, because this one doesn't work here, I can't use that. I can't use 5 either, because that doesn't go in there. So the domain is going to be 1, 2, and 4. The range is going to be 4, 12, and 6. All right. So that's how you use tables to figure out the values. You can also use graphs. You just have to look at the y value. This is just like saying the y value. You can use tables. Or, of course, you can use just equations just like this. Thanks a lot.